All right, calculus. Here we are for video number 2. I think the first one went all right, if I do say so myself. Let's talk about 5B here. Again, this is in diagnostic test algebra. I believe, it's either page 1 or 2. I'll start numbering the pages later on in this big document. I have these notes on this legal pad. Anyway, there is going to be, for that first 3 weeks, things that I'll teach you in class, and then things that you'll have to get down on your own or practice on your own during your days at home. All right, so simplify the irrational expression. We got this times this. This comes straight from Honors Algebra 2. Nothing here will factor. This can factor. That's x squared minus 9, so that's x plus 3, x minus 3. Difference of two perfect squares. 2x squared is going to be 2x and x. There's only one way to get 1. 1 times 1. One of them's got to be positive and negative. That will give you a 1x minus 2x is the negative x you desire in the middle. All right, cancel time. What do we got? North, south. North, south. Leaving you with x minus 1 over x minus 3. This is Chapter 8, Honors Algebra 2, which I taught you. Let's go 5D here. Oh my gosh. This over this. So first off, what we want to do, there's a few different ways. I mean, you can already multiply. In fact, that might have been quicker. You could have multiplied this by the reciprocal of this, which would have been y minus x. In fact, we should probably have done that. Yeah, so I'm going to show you that route too. That's much better. In the past, you might have tried to get this is also not that bad of a way to do it. So I want to get the top to be one single common denominator. So I would multiply this by y over y, this by x over x, multiply it by y over y, x over x, and multiply this by x over x and this by y over y. Now, when I do that, notice xy, 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 xy. I can divide everything by xy. So bye-bye, 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 bye-bye. Leaving me with what I would have potentially. Well, we'll see what could have been the better way in a sec. Leaving me with y squared minus x squared over x minus y. Now, y squared minus x squared is the difference of two perfect squares. That is y minus x, y plus x. Now notice, these are very similar. Y, x, x, minus, minus, but they switch sides. They're opposites, so they do cancel. That would give you a negative 1, leaving you with y, or a negative y minus x. And here's why they're opposites. It's the same thing as saying 5 minus 8 over 8 minus 5. I've seen these on the ACT before, more like this part right here. So here, this is why they're opposites. You get negative 3 over 3, which is negative 1. Now let's take a look at another way I could have done D here. I could have multiplied, because this is this now times the reciprocal of this. So the reciprocal of y1 over, instead of multiplying, or instead of dividing by this, I don't want to multiply by that. I changed my mind. That's not actually going to be very fruitful. So forget that. And there'd be no editing there, so that little gap's going to stay. Anyway, negative y minus x. All right. Negative y. If you, that is the way we're going to handle that one. All right, next page. Diagnostic test, algebra number 6. So we talked about conjugates on the other page. Going to multiply, if I don't want a root in the denominator. So instead, I'm going to multiply the top and bottom by the conjugate of the denominator, which would be root 5 plus 2. Root 5 plus 2. Root 50 plus 2 root 10. Root 5 times root 5 is 5. Minus 2 times 2 is 4. 5 minus 4 is a 1 at the bottom. Root 50 is 5 root 2. Again, if you get that calculator that I showed you in one of the videos, like things to have for day 1, this would do that. It'll break up root 50 for you. Root 5, or 5 times root 2 plus 2 root 10. Divided by 1. Here's another example. Write this down. Root 2 divided by root 3 minus 1. I would multiply top and bottom by root 3 plus 1. Okay, it's going to give you root 6 plus root 2. Root 3 times root 3 is 3 minus 1. 3 minus 1 is 2. Cannot do root 6 plus root 2 and call it root 3 plus root 1. Okay, if it's inside that radical jail, it's protected. Can't divide it. Right. Solve each equation. Cross multiply. Cross multiply. 2x squared. Notice we can't get x equals 0, vertical asymptote. We can't get x equals -1, vertical asymptote. Keep that in mind. Cross multiply, time to FOIL. When I FOIL, I get 2x squared plus x minus 1. Notice the 2x squared is canceled. I get x equals 1, which is okay. See, if I would have gotten x equals -1 as an answer, I would call that extraneous, and my real answer would be no solution. All right, let's take a look at 8D. Again, the ones that I don't put in the video, I would assume we are going to do those in class. If not, there'll be more videos made. Solve each equation. This won't factor. See, I tried. There's only one way to get 2x squared. It's 2x times x. There's only one way to get a positive 1. 1 and 1 there. Middle term's positive, so it has to be that. But that gives you 3x. That gives you 2x squared plus 3x plus 1. That doesn't factor. Quadratic equation time. The quadratic formula is x equals -b plus or minus square root of b squared minus 4ac all over 2a. Yes, you have to have that memorized. B is what is attached to the middle term, A is what's attached to x squared, and C is the constant. So x equals the opposite of b, -4 plus or minus the square root of b squared minus 4. You get that by solving. You can find the quadratic formula by completing the square with ax squared plus bx plus c equals 0. And then plug. I probably proved it for you in Honors Algebra 2. There's C, it's 1 over 2a. Break that up. Square root of 8 is 2 root 2. Now, see, I can divide that, and that by 2, not the 2 inside the root. All right. Ooh, 8G is an interesting one. First off, we love negative exponents when we take derivatives and antiderivatives. We're not there yet, though. So negative power means it is in the denominator, and so if I put in the denominator, it would be to the 1/2 power. 1/2 power is the square root. Now I'm going to move this over, so that's 3 times the square root of 4 minus x. Then I'm going to cross multiply. So 2x is equal to 3 times, when I have the square root of 4 minus x times the square root of 4 minus x. I'm squaring a square root. What is inside the square root will fall out. 5x equals 12. X is 12 over 5. The only no bueno answer would be 4, because then you're dividing by 0. Or actually, what? Anything bigger than 4, because then you get the square root of a negative. That's 2.4, so that's perfect. Do know you need to check your answers. All right, and then number 10 on that last part of the diagnostic test, algebra, this right here. State whether each equation is true or false. I'm going to give you the answers for all these. First off, this is a false, because when you FOIL this, you get this, which is not p squared plus q squared. B is true. Here's why. When I have the square root of a times square root of b, I'm taking the same root of both. I can multiply within the roots. So that is true. Square root of 24 is the square root of 3 times the square root of 8, because the square root of 3 times the square root of 8 is square root of 24. C is false. Here's a little proof why it's false. Let A be 4, let B be 3. Is that true? No, the square root of 25 is not 7. That is not true. Here is what would have been true if you had A plus B, all of it squared. When you take the square root of something squared, that would be A plus B. So notice how it is written differently there. D, let's talk about D. So first off, if I just have a single term in the denominator, I can break it up. You'll be doing that a lot this year. 1 over C plus TC divided by C. C's would cancel there. You would have 1 over C plus T. That is not the same thing as 1 plus T. That is false. Here is E, and here is Y. Sorry, to try to not make that shaky. So first off, to combine these, I would multiply this by y over y, that by x over x. So then I would have y minus x over xy. Those are not the same two things. F is true. Here's why F is true. So first off, I'm going to multiply everything by x. X. Multiply everything by x over x. All right, so here's what's going to happen. X over x is 1. Going to multiply the top by x and the bottom by x. So that means these little numerators are getting multiplied by x. I almost made a mistake down here. Okay, and that's going to give you 1 over a minus b equals 1 over a minus b. Multiply everything by x. X over x. All right, folks, that will take you up to everything in the diagnostic test algebra. All right, my plan is to do the diagnostic text geometry and functions with you in class. So the next videos I make are going to skip those. But again, if we run out of time, I'll just make them once school starts. Folks, this is Yak Math Videos signing out.